Hello girls, welcome to the first digital snow day of the year. As I said in the agenda, today we're going to continue solving quadratic equations. We're just going to see what happens when we get a negative under the radical sign. So first let's warm up using the quadratic formula to solve this equation. So if we look at this, we've got a equals 2, b equals -5, and c equals 4. So if we use the quadratic formula, we get x equals -b, which gives us a +5, plus or minus the square root of b squared minus 4ac all over 2a. So if we simplify that further, we get 5 plus or minus radical 25 minus, and we get -4 times 2 is -8 times -4 is -32 all over 4. So if we continue simplifying, we get 5 plus or minus 25 minus 32 is -7 over 4. So at this point, again, we have to look at that radical, but unlike last class, where we could either simplify it or get rid of the radical altogether, with it having a negative value under the radical, that takes us to a whole nother set of numbers that actually we have, this will be the first time you've seen. So when you have a negative under the radical, there's no number that will multiply to that. Even if it were a perfect square, for instance, even if it were like radical -9, there's no two numbers that would multiply to a -9. So we could have a whole new set of numbers, as I said, which we call imaginary numbers. Now, we talked about this a little bit at the beginning of the year when we were looking at the chart of all real numbers. So today we're going to learn exactly what that meant. So the term imaginary numbers is a group of numbers that are used to factor square roots of negative numbers. So these are numbers that were, I guess, invented exactly for this purpose. And the way we denote an imaginary number is the letter I, and it's always written lowercase. So it's I with a dot, and it is used. The actual meaning of I is to designate the square root of -1. Okay, and you'll see how we use this in a second. So if we took it further and said I squared, which we'll use later also, I squared is the square root of -1 times the square root of -1, which, again, a radical times a radical is always just that value. So we're not going to use this just yet, but for right now, we know that little I means radical -1, and I squared just means -1. Okay, so next we're going to look at how we use this I, imaginary numbers. First, we're going to look at just simplifying the square roots of negative numbers. The steps we're going to follow are, first we're going to factor using -1 and the number we're given. We're going to pull out the -1 and make it I in front of the radical. Then we're going to factor the rest of the number like we always do. So, for example, if we were given radical -9, first thing we're going to do is separate this into its factors of -1 and 9. Okay, so we've just pulled out that -1. Now, the radical -1 becomes an I, and radical 9, just as we know radical 9, can simplify to just 3. So our final answer is 3I. So 3I is just the simplification of radical -9. Okay, let's try another one. So radical -28. So first we want to separate that into radical -1 and radical 28. Radical -1 we know becomes an I. Okay, and radical 28 we want to think about simplifying as we do any radical. What is the highest perfect square factor? And for 28, that is going to be a 4. So we've got 4 times 7. So again, now we can simplify radical 4 becomes a 2. We can't simplify radical 7. So our final answer becomes 2I radical 7. And this gets a little bit, oh, excuse me. This gets you into a little bit into the notation of imaginary numbers. The I always goes on the outside of the radical, before the radical. And if there's another number outside along with it, it goes first. So just as we see in this example. So it becomes 2I radical 7. So the most important part of this is that the I is outside of the radical. You would not want to write it like this, okay, because the I does not go inside. So let's try some more. Do that. So if we look at the next one, we've got radical negative 12. So again, first thing we do is separate it into negative 1 times positive 12. Radical negative 1 becomes an I. Radical 12 becomes radical 4, radical 3. So our final answer is 2I radical 3. Okay. Another example, excuse me, let's look at radical negative 36. So again, we separate it into radical negative 1, radical 36. Radical negative 1 becomes an I. 36 is a perfect square, becomes a 6. So again, our simplification of radical negative 36 becomes 6I. Okay? Now let's look ahead at another example. Okay, so actually, now we're going to talk about exactly where these fit. So this is the chart we saw at the beginning of the year. And we concentrated on this section, right? We even had that on a midterm exam. That's classifying numbers, classifying real numbers into rational, integer, whole, natural. And we also talked about the irrational numbers, such as pi and unending decimals. So this section we're looking at today is this whole other section called imaginary numbers. So they are not considered real numbers. In fact, you cannot even find you couldn't even graph these on a number line, which was part of what we did with the real numbers. So if we're looking at the number line of negative infinity to positive infinity, imaginary numbers are not on there. So kind of gives you just a little perspective. These are non-real numbers, and we'll talk about what that really means in a later class. But the combination of imaginary numbers and real numbers make up what we call complex numbers. So this is just when you have an imaginary number with a real number. And when we write those in the form a plus bi, where the a is the real piece of it and the b is the imaginary piece of it. So just for a couple examples here. This would be a real number, 5 plus 2i, where 5 is a real number, 2i is the imaginary piece of it. 7 minus 3i is again another complex number, where 7 is the real piece, the real number, and negative 3i is what we call imaginary. Negative 8 minus 9i, again, same. Negative 8 is a real number. Negative 9i is an imaginary number. So this just gets you used to the syntax of this, or the proper form, where it's always the real and then the imaginary. So when we have a complex number like that, we can perform operations on them, like just adding, subtracting, multiplying, dividing. Today we're just going to add and subtract. We're going to get into multiplying and dividing when you guys are with me in class. But to add and subtract complex numbers, you simply combine the real numbers, the real terms, and then combine the imaginary terms. You cannot combine real and imaginary when you're adding and subtracting. So it's combining like terms, and it is remember to distribute that negative sign when we subtract. So, for instance, if we want to add 6 plus 3i plus negative 2 plus 4i, so we have two complex numbers, we simply want to combine the real parts first, which would be the 6 and the negative 2, which gives us a 4. And then we combine the 3i and the 4i. And you can almost think about this as like combining variables, although it's not a variable, but we use the same method. So 3i plus 4i gives us how many i's? It gives us 7i. So the answer to this equation is 4 plus 7i. Okay? If we look at example number 2, we can think of 4 minus 3i as a complex number minus 7. So when we combine these terms, again, we look to combine the real pieces, or the real terms, which is 4 and negative 7, which gives us a negative 3. And then we really don't have a second imaginary term, so that negative 3i just comes down. Again, these two cannot combine because one's real and one's imaginary. My colors are kind of messed up here. So again, 4 minus 3i minus 7 becomes negative 3 minus 3i. Okay? It gets a little bit trickier when you're subtracting, just because of that negative. And again, there's not any new rules here. It's just we always need to combine, distribute that negative number anytime we're distributing with a parentheses. So for example, this one, first we might want to rewrite this to distribute that negative and make it 8 plus 5i minus 3 minus 5i. So now we've taken care of distributing. Now we want to combine. So we want to combine the two real pieces. So 8 minus 3i gives us a 5. And then combine the imaginary pieces, which is 5i minus 5i, which actually in this case they cancel out. So we have 0i left. I'm sure you guys can relate to the problems I'm having with the pen here. And actually we don't have to write that 0i. We can just give our final answer as a 5. Okay. Next example, again, similar. We have a real number here minus just we have a complex number here minus another complex number. There's just no real piece to it. So when we could rewrite this really without the parentheses and say 3 plus 5i minus 2i. Sorry about that little random line there. And we combine like terms, which would be just the real piece. There's only one, so we just bring that down. And we combine the imaginary pieces. 5i minus 2i gives us 3i. So that's an introduction to imaginary numbers. And again, all we've done is simplify and add and subtract. So if we went back to our warm-up problem, so I'm just going to click on back to our original, how we warmed up with this. So if we came out with this answer, so 5 plus or minus radical negative 7 for I. So how would we simplify it using what we know now? Well, we would come over to the side, just like we did on any quadratic formula problem with the radical left. We would look at our, oops, sorry about that. We would come over to the side and see, so we're left with radical negative 7. So again, we would try to simplify it. In this case, all we can do is say radical negative 1 and radical 7, and it simplifies to I radical 7, or yes, actually I radical 7. So now we would come back to our answer and complete it by saying the answer to our equation, the roots are x equals 5 plus or minus I radical 7 over 4. So again, just like we learned in class last time, you take the quadratic formula, you get it down to a radical. If it's not a perfect square, you have to come over and try to simplify that radical. Okay, when it's got a negative number, this is as simplified as it can get. So then you insert that back into your equation for your final answer. So our final answer, if we wanted to separate it into 2, would be 5 plus I radical 7 over 4 and 5 minus I radical 7 over 4. So a little bit strange notation that you're really not used to because you've never seen imaginary numbers. However, they're just a new concept. So take a look at, go over these notes as many times as you need to. I've got a blank version of the notes posted on School Fusion. And your homework assignment just entails simplifying some radicals with negatives under the radical and also adding and subtracting. If you have any questions, just let me know, and stay safe over the weekend. And I will hopefully see you on Wednesday. Thanks. Bye.